Here in this page, we can see the full orchestrated dashboard for the services offered by the IoTwins project, in particular for the services developed and deployable during the WP3 work package activity. You can see a series of different services which can be activated. For having the complete list of the services which are available at the moment, not all deployable yet, you can go to the GitLab repository of the IoTwins service page. And for example, let's start by considering some of the available services. Let's look at the general services. The general services are a series of services that can be of broad use for different needs when developing AI-based application. And those are a series of services, pretty simple one that can vary from identifying categorical and continuous feature in a data frame, or encoding categorical feature in a format which is suitable for machine learning models. Most importantly, we have very common services, very common operation that needs to be done to prepare the data to be fed to machine learning model, for example, normalization and pre-processing, which are operation will take place on data set that can be fed to machine learning model for training or inference, and then other services. You can see here that we have a different value, a different number associated to each one of these general services, and then we can see how to interact with the IoTwins orchestrator dashboard to launch one of these services. For example, let's consider again the general services page, and then we can go and click here on the general service. We click on configure button, and then we can appreciate the web page composed by a series of input fields that can be filled by the user. And so, for example, we can start by creating a name for our service, for example, general service 0, to indicate that this is the first one that we are launching. Then we can select a function. We can select the exact services among the list of general ones. Let's go back here, for example, to the list. We can see that a very important service is the pre-processing one. The pre-processing of the data frame consists in preparing the data to make it suitable for training machine learning models. And for example, pre-processing means encoding categorical data, which might or might not be present in the data frame, in the data given as input, and normalization of such data. Okay, so for example, let's specify the service number 5, because this is the pre-processing services, so a very interesting one. Then we can select the number of CPU that are going to be needed by this job. This is a very simple services, so we can rely on a single CPU. We can then select the amount of memory which must be associated to the job. For example, we can specify that we want ½ GB of RAM memory for executing this job. Then there is a series of additional fields that needs to be filled out. For example, pre-processing, the pre-processing service expects the user to provide a data frame in a CSV file format. And this is our requirements for the current deployment of these services. Different alternative solution can be thought, but in this case, we would need to extend the current Python service to deal with different source of data. But let's assume that we can provide the data in the CSV file format. Okay, how can we do it on the UU? How can we do it using the tools provided by the IoTwins consortium? Well, for example, among the other many options, we can use a mini-IO storage area. In the mini-IO storage area that you can access here, for example, through the mini-IO browser, you can create your own, you can access to your own storage, where you can create folder and subfolder. For example, here you see that I have created my own Mini.io bucket. The bucket is the term used by Mini.io to identify an area of storage where I can put data, or I can read data from my machine. So, for example, I have created 3 subfolders in my bucket, and one of those is called data. In data, I have already uploaded a series of different files. For example, CSV file that you can see here, and other files that are specific for, let's say, handling with Python. And we will see some of them in how they're used in different services. But the most important one in this case is the flights.csv. Flights.csv is a very simple CSV file where each row corresponds to a flight from Bologna to Milan. And this is the test data frame that we are going to use for the general services. So I will input the name of the specific services, which is flight.csv. So you can see here, flight.csv is my input file name. So it's the file whose data I want to have normalized in this particular case and categorically encoded, because I am running the pre-processing services on this particular input file. And then I have a series of other fields that needs to be filled out. For example, I need to specify my credential to access to the Mini.io storage. And for doing that, I need to have a Mini.io username. In my case, for example, is Eibor. And these credentials were provided by the consortium, in particular by the INFM partner, who is handling at the moment the access management through the IAM platform. And then we need to specify the Mini.io endpoint, so exactly where the Mini.io service will reside, and in particular, this is the current address. And then we also have to specify the name of the bucket. In the particular case, this is the name of my personal Mini.io bucket. If someone different than me want to use these services, we'll have to create its own Mini.io bucket, its own desired name, and it will be possible to specify a different Mini.io bucket in this case. I mean, this works now because I have already uploaded this specific file in this specific Mini.io bucket. If a user wants to change these values, this is more than allowed after he has obtained from the IAM access management the credential to access to the Mini.io storage area. Then we have other additional values that are needed to access to the service itself, to the deployment part. Those are the credentials required by the orchestrator, and we need to provide the client ID for the IAM service, and this is my particular client ID. I have to specify also the IAM server, which is this one, provided by set up for usage by IoTwins partner. So this is the IoTwins user authentication service. Then we have the IAM client secret, and this is my personal one, and the IAM refresh token. These are all fields, these are all values that needs to be available to access to the service, and those values, these credentials can be obtained by registering on the IAM services. Then you see that I have filled out all the fields of my service. So now I can finally submit my service, and I do it by pressing on this green submit button. And now you see that I'm been moved to a different page. And in particular, this is the list of my current deployment. In this list of current deployment, you can see the last deployment I've just submitted, general service.0, which is that with his deployment identifier, which is this number here, this string here. And you can see its status. Its status is now creation in progress, because at the moment, the OPAS orchestrator has taken my service as input, as specified by my configuration parameter, and it's putting it on execution on one of these machines. Now, have you seen now the services has been actually deployed on a specific cluster, cloud cluster, made available by Cineca, sorry, not by Cineca, but by INFN, with machines devoted to the IoTwins project. And you can see here that I have been assigned a set of machine which belongs to the WP3, because this is a testing environment for WP3. And you see here that the services has already completed. We were earlier in a status which reported create in progress. Now we are in creation complete, create complete, because the services was pretty easy. I have created a very small input file for this specific example. So flights.csv was pretty small. But we can see that in less than a few minutes, the service has already completed. As it really produced the expected outcome, we can see it again using the Mini.io browser, because in this case, this particular service does not provide any output, but it directly creates a new file if everything has gone according to plan. As you can see here, my web browser authentication with Mini.io has expired, so I need to log in again using OpenID. So I just click login because I have already stored my credential on this particular browser. And now let's go back to the bucket created for this opportunity, for this occasion. Let's check the out folder in this case. You see now this last three file, scaler.pickle, normalized label.pickle, and flights_norm.csv are exactly those created by the general service with function number 5. So this is the final outcome of my services, and in particular, it's the original file, flights.csv, but with encoded and normalized data. Normalized data means that we have standardized all the data in order for it to follow within a 0-1 range, which is a representation which is more suitable for a machine learning task. And the data has been encoded in order, categorical data has been encoded in a one-hot encoding scheme. Additionally, together with the actual output of the general service, we have a couple of companion files which are saved using a Python scheme, Python data format, which is the pickle file scheme. It's a format for saving binary file in Python. It's quite a standard format. And we have saved, for example, the scalar object that were used to normalize the data. Once this has been done for a simple reason, and the reason is that okay, now we have normalized, preprocessed the data provided as input to this particular service, but in the future we might want to, using the same normalization scheme, the same normalization approach, we might want to normalize future incoming data. And for this purpose, we can reuse the scalar object provided here. So we can normalize new data not seen so far using the same algorithm and parameters used for normalizing the data provided here in the test case.